we're going to recap on inductance. Some of the topics that involve inductance or particles. For example, we have inductive reactance, which is X sub L. In this formula, 2 pi FL, 2 pi stays constant, that doesn't change. Okay. Frequency does change. We can change the frequency, and we can change the value of the inductor, which is measured in henries. Now, inductive reactance is measured in ohms. It's a value similar to resistance, except it's dealt in AC circuits. We can substitute resistance for X of L and come up with the same formulas, except with X of L substituted in R for resistance. Where in Ohm's law we have E is equal to I times R, I is equal to E divided by R, and R is equal to E divided by I. By substituting these two values, because they're both measured in ohms, they both basically mean the same thing. It's an opposition to current flow. We can come up with formulas that deal with inductance in alternating current. E is equal to I times X of L. I is equal to E divided by X of L. And X of L is still the same as E divided by I. Now, these values for inductance and the value for inductive reactance, when we put them in a series circuit, the formulas are very similar to those as DC resistance. Over here, I wrote down the formulas for both DC and AC. In a series circuit, we know that total resistance is R1 plus R2 plus R3 and so on. Inductance, which is measured in henries, is L1 plus L2 plus L3. Inductive reactance, which is another form of ohms, X of L1 plus X of L2 plus X of L3, so on and so on. These formulas don't change. They're basically the same for a series circuit in both resistance, inductance, and inductive reactance. In parallel, we learned in DC that the total resistance is the reciprocal of the resistors. For example, 1 divided by 1 over R1 plus 1 over R2 plus 1 over R3 is the formula that we use for total resistance in a parallel circuit. For inductance, it's the same thing. 1 divided by 1 over L1 plus 1 over L2 plus 1 over L3 and so on and so on. For inductive reactance, same formula, because this is all in ohms. It's the reciprocal. 1 over X of L1 plus 1 over X of L2 plus 1 over X of L3. So the formulas for inductance and inductive reactance are very similar to those as the formulas for DC resistance. Okay.